or receipts. So I know this is but a review for you. Series of equal payments or receipts occurring at equal interval of time. So annuity may be uh, again taken from the perspective of the borrower and the lender. It differs from the understanding of a single payment cash flow in the sense that, for instance, if we borrow funds today, the expectation is that we would be paying the same amount in a matter of time. Risk paying in equal amounts of time, for instance, in 3 years, in 5 years. So if we borrow funds today, again, the expectation is we will be paying this in equal amounts over a period of time. So we cut it short. For instance, if we are expected to pay this in 15 years, then we would have that as 15 years. So A here, or the magnitude or the amount of payment, would be the same from time 1 to time 15. So supposing we borrow funds which is taken as a value P. So in the discussion of annuity, we are interested sometimes in finding the value of the amount of the loan, the future amount of the loan, the interest rate, and the annuity values. So there are several factors we would have here, but it may be reduced to a use of four factors. So we have the first one would be the uniform series, compound amount factor. Now this factor is used when we try to find an F value when A is given. So for the formula, this is F is A, 1 plus I raised to n minus 1 over I. So for the functional symbol, this is F. So this is read as finding F given A I percent n. If you draw this, then we would have, for instance, something like this. Then we would have the F. So usually A is given, then we find the value F. That is the first formula. The second formula is the uniform series present work factor. This is used when we try to find P when A is given. So yung pong cash flow diagram niya, yung nakasample sa taas. So P here is equivalent to A, 1 plus I raised to n minus 1, I 1 plus I raised to n. The functional symbol is read as P given A, I percent n. For the cash flow diagram, pwedeng ganito ang drawing. To try to find P when A is given. So we add two more factors. So we have three. We call that the uniform series sinking fund factor. This we use if we try to find A when F is given. So it is like you ask the question, if I am to save money now for a specific period of time because I would like to accumulate, for instance, 1 million in several years. So you may define the number of years. Then you ask the question, how much should I deposit? That may be per year or per month or per quarter and so forth and so on. So that is why this is called a sinking fund factor, similar to making deposits on an equal amount. So this is A is equivalent to F, I 1 plus I raised to N minus 1. For the functional symbol, this is read as finding A given F, I percent N. So for the cash flow diagram, if you would like to accumulate, for instance, a million after 10 years, then you might be interested in finding how much you should deposit on a per year basis. 1, 2, 3, 4, kunwari 10 na yan. So this is the value in question. And lastly, you would have the uniform series, capital recovery factor. This is used when we try to find A when T is given. So A is given by the formula. A is P, I 1 plus I raised to N, 1 plus I raised to N minus 1. So if you would see the difference between, for instance, formula 1 and 3, 3 is simply the reverse of 1, 4 is simply the reverse of 2. Meaning, if you would like to familiarize yourself with the different factors, all you have to do is to familiarize yourself with only 2 of the 4. Now, the annuity formula, the use of this annuity formula is more difficult than the use of the single payment cash flow formulas because it adheres to specific rules. There must be a good understanding of the rules so that you may be guided in solving annuity problems. I call these rules the points to ponder. So one is the recognition that engineering economics makes use of the year-end convention. No? So E-ECO uses a year-end convention. That is, we draw the cash flow diagram starting with time 0, then 1, 2, 3, 4, shall we say 5. So if you are to consider year 1, the beginning of year 1 is time 0 and it ends at time 1. When we consider year 2, the beginning of year 2 is time 1 and it ends on time 2. Similarly, we would have the beginning of year 3 is at time 2 and it ends at time 3. Because sometimes the students who draw the cash flow diagram is starting at 1, then it will make now a lot of difference. Again, when we draw the cash flow diagram, we start with 0 because when we say year 1, the end of year 1 would always be 1, the end of year 2 would always be 2, and so forth and so on. That is, E-ECO uses a year-end convention. Number 2 rule has to do with the relationship of P and F. Oh no, that P and A. That is, P occurs one period before the first A. So for instance, if you are asked to find an A value, if an A value is unknown here, one must recall that you may only consider the computation of A if it is one period away from P. So if you borrow funds at time 0, then you can make use of the formula trying to find A for whatever value of I or for whatever value of N, given that the first A in the series is at time 1. The question is that what happens if the annuity is deferred? That is, we borrow funds today and the expectation is that we would be paying 3 months after or 3 years after. So ito po pumapasok sa pagtalakay ng tinatawag natin ng ordinary A. What is ordinary A? An ordinary annuity is an annuity where the first payment starts one period after the commencement of the loan. In cases where you do not pay exactly 1 month after, just like when you borrow funds from government institutions, sometimes when you borrow and your loan is released after the 10th, may mga ganun sila, then you may be expected to pay 2 months or 3 months after. We call that the deferred A. Sa Tagalog, pinagpalibang pagbabayad o annuity, no? So, kailangan pong matandaan, rule number 2, P occurs one period before the first A. So you would ask, how then would I deal with finding an A value when I have to consider the relationship between P and the first A in the series? All you have to do, for instance, if your first A, bawa ito po, no? Gawin natin na deferred. You borrow fund today and the expectation is that you will pay time 2. Kung ganun po siya, time 2. Kung titignan nyo po, it would not adhere to the rule that P occurs one period before the first A, so much so that what you can do is to find the value at time 1, so that time 1 is one period away from the first A, which is equivalent to 2. How then do you do that? You make use of the single payment cash flow, finding F value at time 1, given a P value at time 0. So if your first A, for instance, is at time 6, then you have to compound value of the P at time 5, so that the first A in the series at time 6 would be one period away from the P value at time 5. So that's how you deal with the P and A relationship. For the third rule, deals with with the relationship and F and A. For F, F must occur at the same time with the last A. Meaning, if you have these given values, for instance, if you deposited 1, 2, 3, 4, 5, 6, 7, and you are asked to find the value of F at time 7, then you can make use of the formula. Substitute value in the formula because it suffices the restriction that an F value may be taken at the same time with the last A. But supposing what is unknown after depositing 7 periods, halimbawa times 7 po yan, tas ang hinahanap sa'yo ay time 12. What would you do? You may take an F value at time 7, then compound the value from time 7 to time 12 using the single payment cash flow. Ganun lang po siya mangyayari. Find the value at time 7, but since the unknown is not the value at time 7, but the value at time 12, all you have to do is to find the value at time 7, then the value at time 7 must be compounded to a new value at time 12. Meaning the F value at time 7 becomes a P value at time 12. No? Pag kanina, when you make use of the relationship A and F, no? Ito siya. Value at time 7 is an F value. But when you make use of the single payment cash flow compounding value from time 7 to time 12, then an F value at time 7 becomes a P value relative to the value at time 12. So sa single payment, anything to your left is P, anything to your right is F. Parati pong pag tumingin ka sa single payment, ito ay P at ito ay F. So kanina, nung sinolve mo yan, value at time 7 is F. Pero pag sinubstitute mo na siya, dinala mo na siya dyan, value at time 7 becomes a P value relative to an F value at time 12. Kaya po, hindi pwedeng mawala ang understanding of the single payment cash flow. Number 4, the interest rate to be used must conform with the interval of time for A. So in here is the realization that for two interest rates to be equal, their corresponding effective rates must be equal. In most of the cases where the given would have years as the gap between payments, and if the interest rate is also expressed on a per year basis, then nag-conform na po sila. Halimbawa, nangutang ka, babayad ka, A, ito ay years. No? The description, that is the gap between payment, is expressed in years. And for instance, you are given an interest rate which is, shall we say, 12% compounded annually. When we say 12% compounded annually, we would be dividing the interest by 1 because annual means year. So what we would have here is 0.12 divided by 1 is 0.12 per year. So this is year, this is year. We can make use now of the formula for annuity. The question now is that what happens if the different interest rate, the compounding is different. Supposing it says 12% compounded quarterly. So when you divide this by the number of quarters per year, so this becomes 3% per quarter. Ito po, hindi mag-fit doon. Hindi pwede. So what you can do is to equate interest rates. So you would have here the unknown, and you have here the given. So it is like asking the question, what is that interest rate compounded annually, which is equivalent to the 12% compounded quarterly? So we would have this 1 plus I. So this exponent is 1, meaning 1 time compounding per year. So this is 1 plus 0.12 divided by 4 raised to 4. So you would have that value of I, which is equivalent to a 12% compounded quarterly. So much so that the interest expressed now is in terms of a per year, so then you can fit in the value to the given formula. Kaya po, mas mahirap ang pag-intindi ng annuity, hindi siya ganun kasimple. Other than, of course, the restrictions imposed by the use of these formulas, we also have the recognition that reality would tell us that interest normally is given on a per year basis, but on an actual account of the way we pay our loan, for instance, we do not pay once a year. Parang ang pwede lang bayaran once a year, ilan lang ba? Mga insurance, no? Pwedeng once a year ka magbayad to get insured for how many years. But for instance, we buy cars, we pay for the amortized value of the house. But the expectation is that we would be paying on a per month basis. So The significance of the more than once a year compounding can be taken from the difference between the nominal rate of interest and the effective rate of interest. Again, I'm doing this fast because I know we are all engineers, and I know that you have taken the subject already under the undergraduate program, no matter what engineering program you were when you took your bachelor's program. So this simply serves as a recall. No, recall lang siya kaya ganun po kabilis. Of course, I do not discuss this fast so when I discuss with my undergraduate students. But should you have any question, please do not hesitate to ask. So now we go to the effect of more frequent compounding. So before we start working with the worded problems, kakatingin ko mauubos na yung oras, ilang minuto pa ba? Pag naubos mo yung oras, balik na lang tayo ulit. Siguro ikat na natin, balik na kasi magiging magulo pag hindi. No? Any question before we leave?
So far, ma'am, wala pa.
Sigdan po ba? Oo.
Wala naman po.
Simple lang ito. Alam niyo na to eh.
Ma'am, limot na, ma'am. Nire-recall, ma'am.
Oo. Pero once naman na-recall mo, magiging madali na.
Apo, ma'am. Apo.
Carry yan, carry. So kung wala, Ma'am Aranya, so wala pong tanong?
Wala naman po, ma'am.
Okay, Sir Abing. Sabi, dalawa daw yan pag walang tanong eh. Naintindihan lahat, walang naintindihan. Pero recall lang naman to. Palagay ko, pag nandun na kayo sa maintindihan niyo na. Kasi parang hindi pwedeng pumunta agad dun sa application eh. Nahihirapan tayo kung diretso sa application kasi hindi nyo pa nare-recall.
Yes, ma'am. True po.
Kasi parang si Ma'am Pigdain, how many years na ba?
50 years old na ako ngayon, ma'am eh. Mga 25 years ago.
20 plus. No?
Opo, opo.
Si Miss Aranyas, bata pa to, kaya pa i-recall. Ilang taong ka, ma'am?
Ano po, ma'am? 39 na po. Pero 2006 pa ako. Mga 16
so
po.
matagal na din. Si Sir Abing, sir, kailan pa?
Ma'am, ako po 43. And then,
so matagal-tagal na rin,
2005
no?
po.
Mga 20 years na rin.
Opo.
Actually, bakit nga ba? Sometimes siguro you ask, why is ECO again part of the curriculum for the master's program? Kasi sa totoo lang po, even in UP, when I took the master's in industrial engineering, kasama talagang ECO. Although ang pinag-uusapan, dumidiretso na siya sa net present value, NPV lagi. The NPV application na siya agad. The teacher did not take time to ask, have you still remember your ECO, for instance, the factors, dumiretso na siya talaga agad. So pwede din naman yun kasi ang gusto nila doon, kanya-kanyang aral eh. Kanya-kanyang aral, bigyan ka lang ng problem, mag-solve ka, bahala ka kung naintindihan mo, hindi. Diskarte lang. So, let us end. Kasi mag 10 minutes na lang. Pasok na lang po ulit, ha?
Okay po, ma'am.
Thank you.
Thank you po.
Once a year, pwedeng once per month, pwedeng once per quarter, and so forth and so on. Kaya po, nang-iiba, no? So let us say that the nominal rate of interest, which is the given interest rate, and the number of compounding has not yet been set. So yun lang siya yung given. Supposing we say 12%, but ayaw. Compounded annually. So when we say compounded annually, we would have for the next column the number of compoundings. The compoundings per year. This is normally represented by M. So when we say compounded annually, then number of compounding per year is 1. So when we try to illustrate this, we do have time 0 and time 1. Whatever value we have at time 0 will be brought to time 1. That is, the computation of interest is once per year. Now, when we reflect I is equivalent to Rm, this now defines the interest per compounding period. So this is the interest per compounding period. So this we would have 0.12 divided by 1 is equivalent to 0.12 per year. So one may be able to see that when compounding is once a year, the nominal rate of interest, the interest rate per period will be the same. Kasi ang denominator iba. Now, of course, we would like to see the effect of this number of compounding in what we call the effective interest rate. And this effective interest rate is written as I effective, which is 1 plus R over M raised to M minus 1. But actually, this is similar. Effective interest rate is the actual interest rate of the investment or of the loan for 1 year. So, kung yung ginawa kanina, pareho lang siya. Kasi ang lalabas po dito, 1 plus R over M raised to M, 1 plus R over M raised to M. Now, when compounding is once a year, so this becomes 1 plus I because I is 1 R over M and it's the same as the M is a value 1. So this is 1. So this is 1 plus R over M raised to M minus 1. Now, since the unknown I is raised on exponent, and since the exponent is 1, then we can simply get rid of the grouping symbol. So what is left now of the left side is 1 plus I, which is 1 plus R over M,
raised to
M minus 1. So I is 1 plus R over M, M minus 1. Ito rin po siya. Pareho lang. So, effective interest rate is the actual interest earned by the investment or by the loan in exactly 1 year. So when compounding is annual, I effective is the same as the nominal rate of interest. That is just the relationship between the two. Nirahin ko na po. So when we have the I effective here, this becomes 1 plus 0.12 divided by 1 raised to 1 minus 1. So this is simply 0.12 per year. Pareho lang po. So we add more. What happens now if we have 12% compounded semi-annually? So compounding semi-annually, we compute interest twice in a year. So when we illustrate that, we would have this as 0, this as 1. This is 6 months, or you may have this as 12 months. So whatever value you have at time 0 will be brought at time 6. The interest earned for the first 6 months will form part of the principal and expected to again earn another interest. So we would have that at time 12. So this becomes now 0.12 divided by 2 or 0.06 per semi-annual period or every 6 months. So I effective then becomes 1 plus 0.12 divided by 2 raised to 2 minus 1. Would you be generous enough to give me the answer? If I'm not mistaken, this is 12.36%. But let us validate. Let me get my calculator. I think 12.36.
1 plus 0.12
Calculator.
divided by 2 raised to 2 minus 1. Point 1236
Ano ba ang nasa baba? Wala ang calculator.
0.1236 ma'am?
Tama ba? Mama?
0.1236 ma'am.
Oo po, okay na. Sige, 0.1236. So you ask the question, how is it possible that now interest become 12.36? So it is like when you invest 100 pesos and you are you expect to earn 12%, meaning for every 100 pesos where interest is computed once a year, then you expect to receive 12 pesos,
12
that is
pesos.
12%. But the same amount of investment, 100 pesos, when you invest that at 12% compounded semi-annually, what you expect to receive is 12 pesos and 36 centavos. Now, 36 centavos is a product, is a function of twice a year compounding. That is, the excess 36 centavos is simply an interest of the first 6 months, which also receive another interest for the next 6 months. Yun yung epekto ng more frequent compounding. So let us continue. What happens if compounding becomes on a per quarter basis?
So 3.
So we recognize that there are 4 quarters in a year because 1 quarter is made up of 3 months. So the illustration is that we would be computing interest 4 times in a row. So that is after 3 months, after 6 months, after 9 months, and after 12 months. No? So 1 year pa rin siya.
0.12 divided by 4.
So I is 0.12. This is divided by 4 or 3% per quarter. Hindi mo kasi masyadong makikita yung interest per compounding period. It is like, wala pinagkaiba siya. Yung isa 12%, yung iba 6, hinati lang, hindi mo maramdaman. But when you look at the effective interest rate, this is now where you get to realize, ay, magkaiba nga sila. Nakikuha po.
Raised to 4. Wait ma'am. Point 1255 ma'am.
0.1255.
Opo.
So as the number of compounding per year increases, the annual effective rate also increases. Pataas ng pataas. Let us continue. 12% compounded monthly. The number of
12.
compounding is 12. So this 12 now, hahatiin mo pa siya ulit. 0, 12. So you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you would have I is 0.12 divided by 12. This is 1% per month. So I effective is 1 plus 0.12 divided by 12 raised to 12 minus 1. Parang 12 point, di ko alam, 58 ba? 68?
68 ma'am.
Okay. So yan na po siya. I-continue lang natin. So 12% compounded weekly. Number of compounding is 52. 52 weeks po, hindi 48 ha. So I cannot illustrate. So percentage is 0.12 divided by 52. So we would have percentage per week. So I effective is 1 plus 0.12 divided by 52 raised to 52 minus 1. I think this is 0.1278 o 75.
52
Retuhan lang.
minus 1. 12.73 ma'am.
Okay.
0.1272.
And, okay, they have compounded daily. So when we say compounded daily, the number of days
365.
is 365. So we have I is 0.12 divided by 365. So we have this, the percentage per day. So I effective is 1 plus 0.12 divided by 365. 365 minus 1. So this is
1274, ma'am.
okay. So yan po
75,
siya.
ma'am.
Ituloy-tuloy mo
75.
pa. Okay, 75. So yan po siya. So makikita mo, the more frequent the compoundings are, the higher the expectation for the effective rate. Bakit po siya kailangang maintindihan? Because when you try to solve unwitty problems, if you do not understand this, mali na ang solution sa pag-solve ng worded problem. It is, I would always tell my students in the undergraduate program that you might find the discussion very elementary. So it was like saying, ba yan? Para namang grade school. But I tell you, when you get confused, and it is like you have difficulty solving the annuity problem, it is only when you recognize the difference between the nominal rate of interest and the effective rate that you may be able to solve the problem well. So we continue now. So let us try to start working with problems. So we start with the basic. Wala pa tayong worded. So supposing you borrow 1,000 today and you expect to pay, sabihin na lang natin, in 6, 1, 2, 3, 4, 5, 6, in 6 years. So this is time 0. Ay, 5 lang pala. Ay, kasi mali. Napunta doon yung 0. So we have 0, 1, 2, 3, 4, 5, 6. So you have years for the times. So if interest is, shall we say, 10% compounded annually, you just have to ask yourself, if I would be dividing 10% by 1, because compounded annually, meaning the denominator must be 1, so therefore, y is what? 1, pwede mo nang gamitin yung formula. Otherwise, mag-i-equate ka muna. So if we have this a as unknown, sabi mo, I can make use of the formula kasi ano na siya eh. No? P is at time 0, A is at time 1. The relationship between the value at time 0, which is P, and the first A in the series is at 1. Tama na siya, tumugma na rin ang interest. So, ibig sabihin, pwede ko nang gamitin yung formula. So, you say, A is P, I, 1 plus I raised to N, 1 plus I raised to N minus 1. So, substituting value, you would have 1,000. Then this is 0.1, 1.1 raised to 6, 1.1 raised to 6 minus 1. Will you please give me the answer?
Raised to 6. Wait lang po, ma'am, ha? Raised to 6 minus 1. So, 1,000 times 0.1 times 1.10 raised to 6. Then we have 1.10 raised to 6 minus 1 minus 1. Ay! Raised to 6.
229.61 according to Ma'am Aranyas. 229.61, tama po ba? Let us validate. Tama po ba, Miss Pigkain?
Wait lang, ma'am.
Hindi ko manok kasi wala. Teka nga, bababa ko kung yung calculator. Hindi ko alam kung nasa yung calculator.
Ang sagot, 229. 227 sa akin. Tama ba? Ah, 771. 771. 0.177 divided by the 0.771 times 1,000. Tama, ma'am. 229.
So, pareho na ba? Tama
Opo,
ba?
ma'am. Opo, tama po.
229.61?
Opo.
Okay.
Yes po.
So, may tanong po sa unang example. So, let us try to modify the problem. Supposing now we would have the same A. Five na lang. Then we would like to find an F value. So, if this is years, this is 5, this is 0,
So, yung
I is 10%. We would see na yung huling hulog ko ay supposing this is 100. Nasa pareho ng panahon kung saan hinahanap ko ang F, then ibig sabihin pwede ko nang gamitin ang formula. So F here is A. So we would have 100.
plus 100
Ano pong sagot?
is to 5 minus 1 is to 5 minus 1 0.611 611 divided by 10 times 100. 610.51, ma'am?
Okay. So yan na siya, di ba? Wala pa po kasing more frequent compounding. Simple lang ginamit natin. 3. Halimbawa, itatanong natin. Tinanong natin ang A, tinanong natin ang P. Halimbawa naman, tinatanong natin ang P. Tapos 0, 1, 2, 3. Hanggang 10, 4. So, supposing A is 200. So, P is, if this is 10% and this is years, parang wala ka namang problema other than when you try to find the value of P. Actually, pwede ka pong mag-equation of value, pero pwede rin ganito ang solution. 200 1, 2, 3, 4, 5, 6, 7.
X to 7 minus 1 over 0.10.
Tingnan nyo lang po yung equation. Nag-gets nyo ba?
10. Opo, ma'am. 7. Tapos, 1 point, negative 3. (1.10 raised to 7 minus 1, 0.949 over 110 times 1.10 raised to 7, 0.195.
731.54, sabi ni Miss Arañez.
Teka lang, ma'am.
Sir Abing, will you please validate kung tama?
Negative 3.
Ayos ma'am, for a while lang po. Nagko-compute. Sorry ma'am, di pa po tapos mag-compute.
So this is 0.949 divided by 0.195. Ay, 1.19 divided by 0.195 times 0.751 times 200. 730.97 sa akin, ma'am.
Sa akin din po ma'am, 730.96.
Okay lang po yan, baka rounding error.
Opo,
Ah.
nagra-round up kasi.
Okay.
731, sa akin nga, 7.31.8. Ibig sabihin, okay lang po yan. Kahit ano pa, kasi nagra-round, ano tayo ng value, nagra-round down, nagra-round up ng value.
Opo.
So, okay lang po yan. So, let us have 4. So, hinanap natin. So, naintindihan niyo po ang equation. Actually, pwedeng ganitong gawin. Kumuha ka ng equation of value or use equation of value. I-define mo siya at time 3. So, pag define mo siya at time 3, you would have, so P, no? 1.1 raised to 3 is equivalent to 200. 1.1 raised to 7 minus 1.1, 1.1 raised to 7. Pareho lang din naman lalabas. Pero ito kasi, easier because if you are familiar with the equation of value, meaning at any point in time, when you try to find the value of P, the expected value would be the same. Pwede pong ganon. So let us try isa pa. Posing, meron kang 1, 2, 3, 4, 5, 6. Then, hinahanap mo yung nasa time 12. So, kung naalala po yung kanina, supposing this is 100 also. So, F at 12, pwede ka pong, F at 12 is simply A, i-diretso na natin. So, this is 100. Again, if I is 10%, so this is 1.1 raised to 6 minus 1 divided by 0.1. 1.1 raised to 6. Yan na po siya. Kailangan nyo lang tignan is the equation. Kung naintindihan agad. So, wala na po tayong tanong. Naintindihan ba siya?
Ma'am, raised to negative 6 yung itong 1.10. Raised to negative 6 po, ano?
Hindi po,
6.
positive.
Positive po. Okay po.
Kasi po, papunta ka sa kanan.
Okay, ma'am.
Pag papunta ka sa positive,
Kaliwa.
pag papunta ka po sa kaliwa, negative.
Okay, ma'am. Noted, ma'am.
Okay? So, okay na po tayo doon.
Yes,
So, ano
ma'am.
pong mangyayari kung ganito? Paano po isa-solve? Volunteer po. Gawin nyo sa papel. Sasabihin nyo sa akin na lang equation.
Times 1 to 1.10 raised to 59.
Volunteer po. Sinong magsasabi kung paano isa-solve?
Wait lang, ma'am.
Paano po ang ginawa mo, Miss Aranyas?
Ay, dito ma'am ako nagsagot sa 4. Sa 5 po ba?
Opo. Yung 5. Paano po sasagutan? Pakigawa po sa papel. Tapos sabihin po sa akin ang sagot.
Time raised to raised to 67.68. Saan ba tayo? Ma'am, 2,075? 800? Tama ba ako, ma'am?
Po.
275,000?
275,000 ang sagot,
Opo.
ma'am. Okay,
Ang
tignan
ginawa
po
ko, ma'am,
natin ha.
raised to 59? Tama ba?
Tignan po
59 po ba yan,
natin.
ma'am?
Ito po ang tawag po kasi ito, annuity due. Bakit po siya annuity due? Kasi kung titignan nyo, may laman yung time zero. Kuha po nyo, yung difference lang niya is may laman yung time zero.
Dito sa iba, ma'am, walang laman yung time zero.
Di ba? Iba wala.
Opo.
Kasi ang sinabi dyan, P at A, 1 period ang gap.
Ah,
So, ibig pong sabihin, when you find P here, it must be 100 plus 100. So, kung 59 yan, so yung dulo niya, 59, ibig sabihin 58, 59 pa rin siya kasi wala lang 1 to 59, di ba?
Opo.
Burahin ko na.
bawas ng isa, ma'am, kasi walang laman yung isa.
Hindi, 59 pa rin.
59 pa rin, ma'am.
Kasi
Tama ba?
wala lang naman yung zero, di ba?
Opo, ma'am.
O, ayan po. Ano ang sagot niyo?
100 lang kasi, ma'am, yung ano ko, yung A ko. So, teka lang, ma'am, 10. So, 200 to. So, 275.80.
Yes.
996, ma'am, 0.39.
27,
100 ba kayo?
25.8. 275.8 divided by 27.68 times
1992.78. 78 sa akin.
1,096.
Oo.
Tama ba?
1992 sa akin, ma'am.
1. Did you add the 100?
Opo. 200, ma'am, di ba?
No, hindi ka po pwede mag 200. MDAS.
Okay.
So, 1.1 raised to 59, 2726.8. So, times 0.1, 27.68, 275.8
0.80, ma'am.
divided by answer, 9.96 times 100 plus 100, 1,096.38.
Times 100. Times...
Kuha niyo po.
Opo, ma'am.
Tawag po dyan, unwitted joke.